Hello everybody, how is it going? In this video, I'm gonna teach you how to properly collect data in an efficient way without any labeling effort. So far, we have seen how to create a neural network and how to train a neural network, but it's missing something very important. Data, lots and lots of data. And sometimes it's not so easy to find a proper data set for your deep learning application. As you all know, all this content is for free, so please make sure to smash the like button. That really helps me for the YouTube algorithm. If you also haven't subscribed, please subscribe and activate the notification bell if you want to see more of these videos. So without further ado, let's get started. Welcome back everyone. So as already mentioned in the intro, in this Jupyter Notebook I will show you how to collect data in the correct way and also in an efficient way in order to avoid problems later on while you train your deep learning model. This is a critical step in every deep learning application. So sometimes you can find a dataset online publicly available with no license restrictions, but this is usually not the case. So usually what you really need is to create the dataset for your task and then train, design the model and so on. And also if you go to a job interview, this can also be a question that the interviewer might ask to you. So what kind of ideas do you have how to collect data? What would be your approach? Now, that's very specific, but having an idea on how to be efficient in this direction, this is very important. So make sure you watch the video until the end because I will also give some insight throughout this process. Okay, so let's start. The link of where to download this Jupyter Notebook is going to be in the video description as always. So we can start by explaining why you should care about how to collect data. This is a very important question. So machine learning is data hungry and we all know that. But have you ever asked yourself why? So the short answer is to ensure that the model learns to generalize properly instead of just memorizing the data. Okay? So we can train a model with 50 examples. The problem is that it's just going to remember those 50 examples and it doesn't really learn. It just remembers what it's seen. Okay? So we want to avoid that. Research has advanced a lot lately, and you might have heard of one-shot or zero-shot learning. And even if these techniques are very promising, are not always applicable. In machine learning, if we don't pay attention on what data we use for training, and especially testing our model, we might have to deal with a model that works very well on data we have used for training or testing even, but in real-world scenarios, it doesn't work. As you can imagine, this causes big economical problems for companies. Because after all the effort to collect the data and eventually label the data, it might be possible that data has to be recorded again and labeled again. Okay? Because the way that we created the data set is not done efficiently or properly. Okay? So it's not just about cost effective, it's also on how to ensure that the data it's good for our application. Okay, so before we go into the coding part of this project, let's see what components we're going to use. Of course, we will need two objects that we need to identify. In this case, I just used two Lego cars, but you can use whatever you want. This is going to be a show for a classification kind of task. So it can be a binary classification or multi-class classification. It doesn't really matter. But you will see that this concept can also be applied for any kind of image. Okay, so we will work with images. And also we can use it for concepts like, for example, object detection and semantic segmentation. You can choose any kind of object you like. It really doesn't have to be those two, of course, but make sure that those are not easily differentiable by color. For example, an orange and an apple. That would be too simple to classify. Next, we're going to use a simple USB webcam. Make sure that you also buy a standoff together with the webcam. It's going to be handy later on when we collect images. If you don't want to use the webcam, you can simply use a Raspberry Pi camera and it's going to work just fine. Next, we're going to use a simple paper background, just simple paper of a color of your choice. I recommend you to use either green or blue. We will position this behind the objects that we want to classify. It's going to be useful for us during data augmentation. Last object we're going to use is this device that is used usually in shops to show their merchandise and is simply going to spin all over 360 degrees. So usually you can just position object on top, then start it, and as you can see, it just turns around 360 degrees to show the merchandise. In our case, we will position an object on top of it so that we can capture every angle of this object automatically without turning the camera all around the object. You're gonna find all the affiliate links in the video description. Okay, so here the idea is pretty simple. We want to have a clear distinction between the background color and the base color and the object itself so that we can remove it later on with some pre-processing and some data augmentation, as well as having some good light for our objects that we want to classify. We need to pay attention also on the light, because if there is too much of light and a lot of reflection or too less light, then it's kind of difficult to pick the color, to remove the background, okay, just by picking the color. Okay, so now let's dive into the coding part. So first thing we need to do is to ensure that we are using the Python 3 virtual environment, so not the TensorFlow 2 or the PyTorch or the others. Then we can execute this code, so then we can start to import all the necessary libraries for this project. Okay, so the first thing that we're going to use here, I created a class called config, which contains all the information that we're going to need for the camera settings. Okay, so what about the crop size? How do you want to resize the image afterward? And what index the camera has, and all this stuff. So you can start with the default values, and then I will show you now how to what effects you have on the image. Okay, so the code now is pretty straightforward. So basically, we're gonna open the camera. Then we're going to read one frame, so take one picture. We convert the color from BGR to RGB, so we just change the order in which the channels are stored. And then for the beginning, we just keep the code like this, so that we just draw a bounding box on the rectangle that we want to crop. Why this? Because we want to adjust, first visualize how our cropping fits into the object, and then after that we have adjusted those parameters, then we can actually crop the image. So we can execute this code. As you can see, after this drawing the bounding box, we show the image, and as you can see, in this case I already prepared it before, so we can see that the bounding box fits perfectly the object itself. As you can see, is a pretty good and clear distinction from the background and also the base and the actual objects that we want to classify. This is very important, so make sure that there are not some kind of strange lights reflection or too much of darkness, because then when we want to remove such a image, such a background, okay, we're going to use some color thresholding, okay? So of course, if the bounding box doesn't fit for you, you can just go up here, change, for example, x1 and y1, so the upper left corner, and then x2, y2 is the bottom right corner. So by adjusting those 4 parameters, make sure that the bounding box fits in the image. Okay, so something like this. Once that's done, then what we need to do is to go again to the same code cell. Then we're gonna comment out this line of code, so we're not gonna draw bounding boxes anymore. And instead, we're going to crop the frame at the specific bounding box location. And then we're gonna resize the image to the image size that we created. So 224 by 224. Why do I want to resize the image to this specific size? The reason is pretty straightforward. So later on in the course, we're going to use a lot of pre-trained networks that have been trained on this size of the image. Okay. So this is not something that we have to do it right now. So it's not mandatory. What is mandatory is that every image has the same size. Okay. So not that some image is bigger, some image is smaller. Otherwise, we need to do this processing afterwards. So just to make sure, since we're going to record also the camera in different positions, then we need to have a consistent image size. So that's why I resize it to this dimensions. So now that those two lines have been commented out, then we can run the code again. And now we should see, the new picture. As you can see, this is pretty straightforward. So we just crop the image to where we want it to, and then we resize it to the dimension we want, and then we visualize it. So now we create a function to collect data automatically. So as you already got the idea, basically we're going to spin the object and then keep on recording images, applying the same pre-processing that we have done so far now. So we crop the image, we resize it to 224 by 224 pixels, and then store the image in the hard disk. So the function is pretty straightforward. It's going to ask like where you want to save the data, in which directory, if you want to overwrite or not. So if you want to delete everything that you have recorded so far. A delay, why? Because by default I think it should be like 30 frames a second if the camera supports that, but should every camera support that kind of frame rate? And the duration, so for how many seconds, okay? The delay is in seconds between each camera shot, and we don't want to have this 30 frames a second. The reason is pretty straightforward. It's going to be almost the same image. Depending of course on the speed, rotation speed of this device, that is pretty slow actually. It really is not necessary to have lots of data where you have like slightly minimal variation between the images. So let's go quickly through the code. So first I make sure that the directory gets created if possible, and if specified, so if we say we want to overwrite everything, then it's going to delete all the existing images. Then we're going to repeat the same process that we did before. So we open the camera, and here we count the steps, okay? And then we read one frame, crop and resize the image into the desired size. And then we save the image with a unique name. This is important, otherwise we're going to overwrite the same image. And then we just print the step, and we sleep for a certain amount of delay that we have specified. And after that, we simply close the connection with the camera. Okay, so now it's time to finally record the data. So first thing, as you saw, you can start with any position. It doesn't really matter. Just start with one specific position and make, you will see here in the code, basically I said, okay, I say in which directory. I will call it, for example, object1, and then I don't want to overwrite it, and the delay is 0.2, so every 200 milliseconds I'm going to take a picture on the object, and the duration is 24 seconds. And how do I get to this number? Because I simply calculated that to make a 360 degrees complete revolution, the object takes roughly 24 seconds, so not to have double data, okay, so like repetitive data. I just want to make one complete round of 360 degrees, which will take roughly 24 seconds. So we can execute now this code, and as you can see now it starts to show progress bar. More than a progress bar, some informations about how many images are being processed. Okay, so now it's done, and as you saw, we collected 120 images about that object spinning, of course, so make sure that this device is running, of course, turning. And this took really a few seconds. Now, does this mean that this is perfect data set for our use case? No, definitely not. Why? Because of course we don't have many examples. This is the first point. The second point is that we have only one angle of view. This is very important. So if you collect data like this, in a very static environment and all prepared and with the perfect light and everything, so like this, you will have a strong bias, very, very strong bias. So what you want to do as a next step is to change the position of the camera and run the function again. As you can see now from the new image, I've changed the position of the camera so that I can capture a different angle. Of course, as I have adjusted again the bounding boxes to where to crop the image. And of course, this is a repetitive process. So what we are going to do is then, after adjusting this, of course, and figure out everything is fine, of course, we want to visualize first that the image looks good, uncommenting those other two lines. Once that's done, of course, we can call this second code cell. So we want to give a different name for the directory. This is also very important. So we give different angles. So if we give different angles, we want to make sure that also the data there is balanced, right? We don't want to show only angles, only picture from a specific angle and just like 2 or 3 pictures from a completely different angle. So we want to have a pretty much homogeneous data set. So since we are in charge of creating the data set, we want to have full control of it. So in this case, just by changing the directory name to something like object1_top, if it's from the top or from the side, or you can name it whatever you want, but then make sure that you use also the same kind of delay and duration so that we are still going to collect another 120 images in this case, okay? So let's make sure that everything is balanced. We don't encounter some strange kind of imbalanced data set, even though the class is still the same, but you have a different angle and you don't have enough samples and so on. So we want to do this for many different angles for the same object and then repeat the same procedure for different objects. Okay, so in this case, we're going to have 2 objects. In your case, you can have multiple objects and you can do this all over and over. Okay, so now that we have collected a lot of data for all our objects, in all those different angles, we want to store this data into a more efficient format. Okay, so we're going to use HDF5 file like we use for lesson 8. So we can use this code cell to do that. In this case, I only have created this folder object1. In your case, you might have way longer. This is just the list of folders that you guys have collected. So all the names that you have specified with the relative paths. In my case, I have only object1, as you can also see here from the screen. So I can execute this code and the data here is stored. Now we can, to double check that everything went fine, we can execute this code. Okay, so as you can see, we have in this case, only one data set, which is object1 with the shape 120 by 224 by 224 by 3. 3 is because, of course, we have RGB channels, so 3 channels. That's the size that we specified, and 120 is the number of images that we have recorded. Okay, so pretty straightforward. Now, what do we need to pay attention? What I would like you to show, try again to collect data. Okay, so create another data set, but instead of creating a bounding box very close to the object, create a bounding box that it's pretty far. So you still want to make sure that you don't capture all the other colors around so that you can still crop it, okay, later on. So maybe you might need a bigger carton paper, okay, a different green paper. But try to make it like, I don't know, like if this is the image, try to make something like a square of from this pixel like 200 to 50 till this other corner 1750. So like that, you really get a way bigger bounding box. Now, if you have experience with deep learning and you've done a lot of projects, you might already foreseen what is going to happen if you have such a case. So I want to give you a hint. So does this way, what I just showed you so far, means that we are going to create a perfect data set for our application? Yes and no. It depends on what the application is, of course. So if we only consider, if you have noticed, what we do is pretty narrow. So we always capture a pretty precise bounding box with very good light condition, take it from different angles, so this is good, but the light is consistent and the bounding box is consistent. Meaning, what's going to happen then when you go to real life? So it depends on what application you're trying to do, then you might have problems. So I want to leave you with this question. What if you train your model, assuming that everything works fine, let's say that you're going to have a bounding box way bigger, okay, as your pre-processing step, so you don't really crop nearby the object. What's going to happen to your machine learning model prediction when it makes a prediction? What do you think is going to happen when you have a complete different bounding box and maybe even completely different light condition? And what would you do to solve such a situation? If you have problems, how would you solve those problems? I leave this as a bonus question, so make sure you comment down below and we will answer this question in the next video. Whether you want to implement AI into your business or you just need consultancy from a machine learning expert, I'm the right person for you. From acquiring data till deployment, my multiple years experience will provide you full support which will help you to boost your business. To find out more, check the link in the video description. So that's it for this video. If you guys like my content, you can support me on Patreon, where you can speak directly with me, and also I can give you advice on how to get started into this career. Another way to support this channel is to use my affiliate link that I give you in the video description for your purchases at no cost for you. Finally, another way to support me is to subscribe and share this video on social media. So I thank you for now and I hope to see you in my next video.